guys, Mrs. Traver here. Today we're going to look at 113, quadratic functions. Learning target is to be able to look for a pattern and complete diamond problems and be able to solve equations with variables on both sides. You'll know you're successful if you can find numbers that multiply to a specific number and add or subtract to a different specific number. Those are the diamond problems. You'll also be able to isolate variables on one side of an equation. Today we're going to look at yesterday's answers to our homework, take notes on graphing quadratics, and then do a homework assignment on those graphing ones as well. So let's look at first our answers from yesterday's assignment. Here they are. Pause your screen now to check them out. Notice the no solutions and all real number problems. And then here's the rest of it. Pause your screen to check those out. If you have any questions on the ones that you might have got wrong, feel free to visit me on Zoom during the last 15 minutes to ask any questions you might have. Moving forward, we're going to take notes today on quadratic functions. So I've got a lot going on in my paper. Take a minute and pause your screen. We're going to do several problems with this same setup. So you're going to have a graph and you want to label it and make it pretty. So see if you can have these little marks. Those little marks will help you notate how far over you're going and up you're going. So get some graph paper going. If you have graph paper, that's like ideal. Other than that, you're going to need a table for each one. Oops, whoa, sorry. You'll need a table for each one, and I've got some spots for each. So if you want, pause and get where I'm at, because I know that'll take a little bit of filling in. All right, let's see what we can do here. So we've got lots of stuff going on. This table is what's going to happen first for us. So I want to build an XY table, and I left myself a spot in the middle here to do some work. So this is where I use my y equals. So I know y equals x squared plus 1. We're going to end up graphing these. The formula, I'm sorry, not the formula, the equation is called a quadratic. It graphs what's called a parabola. It's a U-shaped graph. So we're going to find out what happens here. And I need to plug some stuff in for x and evaluate it at x so I can see where the y point is. And then I'll end up having some coordinates to plot. I want to pick nice numbers to plot, so I just want to pick some pretty ones like -1, 0, 1, 2, and like that. Actually, what I'm going to do is use up this space on here. I'm going to bump this up a little bit. How about I do it like this? There we go. So let's try these numbers. -1, or let's do -2, sorry. -1, 0, 1, 2. We'll use these for all of them, actually. They're nice, easy numbers to plug in, and we'll see what happens when we do it. So if I plug in a -2, I'm going to have y equals something squared plus 1, and that something in this case is -2. Matter of fact, all of these, the work is going to look the same. It's going to be something squared plus 1. So you can fill that in for each of these. It might make it a little bit easier so you don't make a mistake when you are evaluating. So there we go. I plugged all those in, and I just need to change the number for each one. This one's going to be a -1, a 0, a 1, and a 2. So you can see how it changes. Let's see what y equals when we simplify. -2 quantity squared is -2 times -2. That's 4 plus 1. Y is 5 on that one. Next guy, I've got -1 quantity squared. -1 times -1 is just 1 plus 1 is 2. On this guy, 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. Ooh, another 2. 2 squared is 4, plus 1 is 5. This looks kind of cool how it went 5, 2, 1, 2, 5. We'll notice something about that when we graph it. We've now got 5 points to graph. We've got the point -2, 5. Let's plot that. -2, that's left 2 on the x-axis, and up 5 on the y-axis. So there's my first point, -2, 5. Next point, -1, 2. So left 1, up 2. Whoop, left 1, up 2. And next point, 0, 1, that's just up 1. 1, 2, right 1, up 2. And 2, 5, right 2, up 5. Notice it kind of looks like it made a V. It actually makes kind of like a U. So make sure when you connect these, we want to kind of curve it. So I'm going to do my best to curve it at the bottom. Don't make it a V. So there is our graph. And it is called a parabola. That's the shape of that graph. So let's fill in the other things that are going on here. Axis of symmetry. Symmetry is when you could fold something and the line that it makes. So I think of symmetry like if you had a butterfly, you know, each side matches itself down the middle. So that line is where the line of symmetry is. So the axis of symmetry on this one is actually right down the middle, if you can see my blue over right. So my axis symmetry, it's right down the middle on the y-axis. The equation for the y-axis is x equals 0. My vertex is next. Next, we're going to look at our vertex. Our vertex is the point that touches that axis. So for example, here, it was this spot at the bottom. That was the point 0, 1. That's our vertex. Maximum or minimum is talking about the vertex. If the vertex was at the bottom, it's a minimum. If it's at the top, it's a maximum. So because it's on the bottom, this is a minimum. X-intercepts and y-intercepts. X-intercepts is where it crosses the x-axis. Let's look at the x-axis. Doesn't cross, so there's none for this one. The y-intercepts where it hits the y-axis. If you look through the y-axis, it does hit it right here as 0, 1. All right, let's try another one. I know that felt like a lot. Next problem. We're going to do the same thing here and use the same points. -2, -1, 0, 1, and 2. And I'm going to rewrite this every time, and instead of an x, I'm going to use a parentheses. So y equals negative something squared plus 4, negative something squared plus 4, negative something squared plus 4 for each one. All right, and then let's plug in each of our numbers. The first one, -2, -1, 0, 1, and 2. That way I make sure I don't make any mistakes as I'm plugging in. I've got -2 squared. That's -2 times -2. This piece gives me a 4. But I can't mess out this negative, so this negative is going to come right here. -4 plus 4 is 0. So there's the first point. Let's plot it as we go this time. -2, comma 0. That's left 2, up none at all. So there's our first point. Our next point is at -1. So -1 quantity squared, that's -1 times -1, or just 1. Now I'll throw that minus sign on it and add 4. -1 plus 4 is 3. Let's plot the point, -1, 3. Left 1, up 3. Our next one is at 0 something, so 0 quantity squared is 0. I don't need to make 0 negative, that's not a thing. 0 plus 4 is 4. Let's plot the point, 0, 4. Our next one is negative quantity 1 squared plus 4. 1 squared is 1. I'll throw that top negative in front of it. -1 plus 4 is 3. I've got the point 1, 3. Notice how I've been graphing this as I go. I feel like I might already know where the next point's going to be because I know this is symmetrical and it already took that turn. So through this axis of symmetry, if this is going to fold over, there should be another point right here. I think that's our next point at 2, 0. So I'm thinking this is 0. Let's check it. -2 quantity squared plus 4. 2 squared is 4. Throw the negative in front and then plus 4, and it is 0. So sometimes you can fill in your table if you notice the symmetry without having to do all the problems out. So here's our parabola. I'm going to put some arrows on the end to show it goes on forever because it could keep going on and getting more points on either side. We already drew in where our axis of symmetry is. It's right on the y-axis again, which is the equation x equals 0. Our vertex is the one that touches the axis, and in this case, it's on the top here. That's the point 0, 4. And it is at the top of the graph, so it is a maximum. X-intercepts is where it hits the x-axis, so looking across the x-axis, I see a point right here. That's the point -2, 0. And there's another time it hits right here at 2, 0. The y-intercepts where it crosses the y-axis, it hit right here at 0, 4. Sometimes for x and y-intercepts, instead of putting it as points, you could have said it's at -2 and 2. And for this one, we would have just said 4. Don't put parentheses around these, though. I should really say and. Let's try another. We're going to do 1, 2 more before you try your worksheet. So we've got a couple more to go. If you feel good to go, feel free to hit stop and go try that assignment. But if you want some more examples, here's one. Here's one that actually has a third step in it. So let's see. We'll try the same points, -2, -1, 0, 1, and 2. And I'm going to set myself up each time something squared plus 2 times something plus 1. Something squared plus 2 times something plus 1 each time. All right, let's see. Let's start at the top, plugging in -2. So for this one, -2 goes in for both of the x spots. -2 quantity squared is 4. -2 times negative, or 2 times -2 is -4, and then plus 1. Okay, let's see, 4 minus 4, left to right, right? 4 minus 4 is 0, 0 plus 1 is 1. Okay, there's our first point, -2, 1. Left 2, up 1. Next one, we're going to plug in -1s. -1 quantity squared is 1. 2 times -1 is -1, or sorry, -2, and then plus 1 at the end. 1 minus 2 is -1, plus 1 is 0. There's a point in -1, 0. Next one, I'll plug in zeros. 0 squared is 0. 2 times 0 is 0, plus 1. Oops, why did I write that? So this one should be 0, 1. 0, 1. Ooh, can you see how this is going to look? If I just connect these three, I already have a good idea of what this is going to look like. Let's plug in the next one and see what happens. 1 is going to go in these spots. So 1 squared is 1. 2 times 1 is 2, plus 1. 1 plus 2 is 3, plus 1 more is 4. So there's a point at 1, 4. All right, plug in some 2's. 2 squared is 4. 2 times 2 is 4, plus 1, that's 8, plus 1 is 9, 2, 9. That's actually 1 up here, I think. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's kind of way up there off my graph, but not too far off my graph. So let's look at this one. We know parabolas are symmetrical and they go on and on forever. So I can actually imagine where the rest of the points would be. If I know that this is going to be symmetrical, there's that line of symmetry going down the middle. I do that dashed. There's actually going to be another point over here because it's equidistant away. And there'll even be another point over here that I could imagine if I had plugged those in, those would be there as well. So notice that even though we didn't do the table for it, we know they're going to be there based on how it's symmetrical. Okay, let's fill in our stuff. Axis of symmetry, this time it was left 1. So that's at -1, x equals -1. Our vertex touches the axis of symmetry, so it was right here at -1, 0. And it was at the bottom, so it's a minimum. X-intercepts, it crosses the x-axis here at -1. Y-intercepts, it hits the y-axis here at +1. All right, we have one more to go. Let's see, let's plug in our -2, -1, 0, 1, and 2. And each time I'm going to say negative something squared minus 1, negative something squared minus 1, negative something squared minus 1, and so on. All right, here we go. The first one I'm plugging in a -2. -2 quantity squared is 4. Then this front negative comes in, -1. -4 minus 1 is -5. Next one I'm plugging in a -1. -1 squared is +1. Then I'm going to move over this negative and -1. -1 minus 1 is -2. I should plot these. I forgot the first one. -2, -5. So left 2, down 5. My next point was -1, -2. And now I'm ready for my third point. If I put in a 0, this whole thing goes away and I'm just left with -1. So 0, -1. If I put in a 1, I've got 1 squared is 1. Put the minus in front of it from here. -1 minus 1 is -2. So 1, -2. Notice on your graph, can you tell where the next point should be? I think it'll be there. This is the point 2, -5. I already can fill this one in. I don't even have to do the work here, plugging this in, because it's gonna match. That symmetrical thing not only works for the graph and this picture, seeing the line of symmetry, there's also that line of symmetry within the table. So notice here, on either side of this spot, there were the same numbers, -2 and -2, -5 and -5. That's because this spot, 0, -1, this is the vertex. So everything on either side of it's the same. Let's fill it in while we're talking about it. 0, -1. And our axis symmetry went through the middle again. That's right there at x equals 0. That's a line. That line and dashed. The axis of symmetry touched our graph at the top, so that means it's a maximum for a vertex. And the x-intercepts, it did not ever cross the x-axis. Even if it goes on and on forever, it's never going to hit this x-axis, so there are no x-intercepts. Y-intercepts, it hit the y-axis here at -1. All right, I think you are ready to try an assignment here. You've got some more practice on graphing quadratic functions that look just like our notes. If you are stuck, use a Desmos calculator. Let me show you that real quick so you can get an idea of how to get to it. There is a resource on our website that'll get you there. So let me show you that. If you go to resources, and then here there's Desmos graphing calculator. So if you click that, it'll open up and you can put in anything you want here. So say I was trying to type in y equals x squared plus 4. To get to the squared, there's a caret button. It looks like an arrow up. It's on the 6 key. Use shift to get to it. And it'll automatically make yourself be in exponent land. You can put the 2 up there to do a squared, and then arrow to get out of that, and then say I want to do plus 4. That's my graph. You can even touch points on it. So there's a 0.15, and I can click and drag as well. So this is helpful to check your work and see what it should look like. You can zoom out or in as much as you want. All right, guys, that's all I've got for today. I hope you've had a good time. If you have any questions on your assignment, come ask me on Zoom, and I will see you next time. Bye.